Dear students, let us learn another method of evaluating trigonometric ratios of angles greater than 90 degrees. Now this method is nothing but combination of method 1 and 2. So let us divide our page into two parts and discuss angles simultaneously. Let us take a 120 degree angle which is greater than 90 degrees of course, and it is lying in the second quadrant. Say we have to find cos of 120 degrees. We can write that as cos of 180 minus 60 degrees. So that means basically we are finding our reference angle, which is coming here when we write 120 as 180 minus 60. Now since x-axis is our reference line, so we know the rule that it will remain same, the ratio remains same. So this will be cos of 60 degrees, but cos is negative in the second quadrant, so it is minus cos 60, and hence cos 120 degrees is equal to minus 1 by 2. Let us look at the same angle with y-axis as the line of reference. Say again I have to find cos 120 degrees. We can write it as cos of 90 plus 30 degrees. Now basically this 30 degrees is our reference angle with respect to our y-axis. So as the rule suggests, cos will change to sine when the line of reference is y-axis. The ratios are changing of the reference angle, and since cos is negative in the second quadrant, so a negative sign here, and this gives us again minus 1 by 2. So clearly we have seen that if our angle is lying in the second quadrant, it is up to the student whether to write it as 180 minus theta form or 90 plus theta form. When we are writing in 180 minus theta form, we are basically taking x-axis as the line of reference to calculate reference angle, and when we are writing it as 90 plus theta form, we are taking y-axis as the line of reference for calculating reference angle. Let us take some more angles. Say our theta is 135 degrees and we are asked to find sine of 135 degrees. We can write it as sine of 180 minus 45. Then 45 is the reference angle and x-axis is the line of reference. So sine will remain sine and it is equal to sine of reference angle. Also sine is positive in the first quadrant. Hence the answer is 1 by root 2. Let us look when y-axis is the line of reference for calculating reference angle. Again, say we have to calculate for 135 degrees. Sine of 135 degrees is equal to sine of 90 plus 45 degrees, which is equal to sine will change to cos of the reference angle, which is 45 degrees now. Sine is positive in the second quadrant and hence Our answer is 1 by root 2. Here students can also note that when we want to keep a ratio same, that means we want to keep cos in form of cos only, sine in terms of sine, then use x-axis as the line of reference for calculating reference angle. While when we want to change cos to sine, sine to cos, tan to cot and vice versa, then we need to take y-axis as the line of reference because the ratios are changing when we are taking y-axis as the line of reference for calculating reference angle. Let us take another angle, say 150 degree angle in the second quadrant, and say we want to find tan of 150 degrees. That can be written as tan of 180 minus 30 degrees. Now x-axis is the line of reference, so tan will remain tan and reference angle is 30 degrees now. Tan is negative in second quadrant and hence minus 1 by root 3 is the answer. Similarly, let's do the other side. Tan 150 degrees is equal to tan of 90 plus 60, because now this is the reference angle, which is equal to, now tan changes to cot of 60 degrees and tan is negative. Again, our answer is 1 by root 3. Now let us look at some angle in the third quadrant. Say this is 210 degrees and we have to find sine of 210 degrees. We will try to write it in the form sine of 180 plus theta. So it can be written as sine of 180 plus 30 degrees. Now this 30 degrees is actually the reference angle and we know the rule because we are taking x-axis as the line of reference. So sine is going to remain as sine. Reference angle is 30 degrees and sine is negative in the third quadrant. So answer is minus 1 by 2. Let us consider y-axis as the line of reference to calculate reference angle. Again, let this angle be 210 degrees. Then reference angle will be given by 270 degrees minus 210 degrees. But we are going to do it like sine of 210 degrees is equal to sine of 270 minus theta. So 270 minus, we can write that as 270 minus 60. So now this is our reference angle. We can see clearly. Here also we are getting 60 only. So this is equal to, now y-axis is the line of reference for calculating the reference angle. Hence, sine will change to cos of the reference angle and sine is negative in third quadrant. So a negative sign and this is equal to minus 1 by 2. Let us consider an angle in fourth quadrant. Say we have to find 315 degrees. Sine of 315 degrees. Now this can be written as, if we are taking our x-axis as the line of reference angle will be this one. But without going into that, we can write sine of 315 degrees is equal to sine of 360 minus 45 degrees, which is equal to, now since 360 means x-axis is the line of reference, so sine remains sine, reference angle is 45 degrees, and sine is negative in fourth quadrant, so we get minus 1 by root 2. We could have done the same question as taking y-axis as the line of reference. 315 degrees here. This is the reference angle, and we know this is 270 degrees. So sine of 315 degrees is equal to sine of 270 degrees plus 45 degrees. Now we can apply the rule. 45 degrees is the reference angle, but y-axis is the line of reference. So sine will change to cos of the reference angle, and sine is negative in second quadrant. Sorry, not the second quadrant, fourth quadrant. So this gives us minus 1 by root 2. Let us also look at an angle in first quadrant. Say this is 60 degrees. And we are supposed to find sine of 60. Then taking x-axis as the line of reference, no need to do anything except to use your table and directly write the value. But when we are taking y-axis as the line of reference, then sine 60 can be changed to sine of 90 minus 30 degrees. Clearly, this is the reference angle. So now the rule applies. Sine will change to cos as y-axis is the line of reference and sine is positive in first quadrant. So sine 60 is equal to cos 30, and which is equal to root 3 by 2. So I would like to sum up this study of calculating the angles by saying that it will be up to the user to analyze the question and see whether he wants to keep his ratios same, means he wants sine, for sine of any angle theta, he wants to get sine only, then he should take x-axis as the line of reference. While if the question demands to change our ratios from sine to cos, tan to cot, or sec to cosec, and vice versa, then we should be wise enough to choose y-axis as the line of reference.